This is the final video in our series Getting Started with Python on Windows 11. In the first video, we used winget to install Python from the command line. In the second video, we created a project folder, set up a virtual environment, and installed packages using pip. In this video, we'll bring everything together. We'll install JupyterLab, an interactive development environment that runs in your browser, and write our first Python code. Let's open the Windows terminal. You can press the Windows key and type terminal, or right-click on the Start button and select terminal. First, we need to navigate to our project folder, and then activate the virtual environment we created in the last video. We can see .venv in parentheses at the beginning of the prompt, confirming our virtual environment is active. Everything we do from here will stay within this project environment. JupyterLab is just another Python package, so we'll install it the same way we installed NumPy and pandas in the last video. Simply type pip install JupyterLab. You'll notice JupyterLab pulls in quite a few dependencies. On my system, it installed over 80 additional packages, and this is normal. JupyterLab is a full-featured development environment, so it relies on a number of supporting libraries. Once the installation completes, we can confirm it's available using pip list. You can see JupyterLab and its many dependencies now appear alongside the packages we installed previously. Remember, everything is contained within our virtual environment. To start JupyterLab, the command is simply JupyterLab. Two things happen here. First, the terminal starts a Jupyter server. You'll see log messages scrolling by, and second, your default browser opens automatically to JupyterLab's interface. One important note, the terminal window must stay open while you're using JupyterLab. It's running the server behind the scenes. If you close the terminal, JupyterLab will stop working. This is the JupyterLab launcher. You'll see tiles for creating different types of files. The one we care about is the notebook tile under the first group. This is where we'll write our Python code. Let's click the Python tile under Notebook and create our first notebook. You now have a Jupyter notebook. It's called simply untitled.ipynb. The notebook is made up of cells, and right now we have one empty cell ready for code. If you've used Google Colab or taken a data science course on Coursera, this will look familiar. Jupyter notebooks are one of the most popular ways to learn and work with Python because they let you write code, run it, and see the results all in one place. So let's write something. In this first cell, type import numpy as np, and then np.sqrt9. The first line imports the numpy package and gives the alias np. This is the widely used convention, and you'll see it virtually in every tutorial and textbook. The second line uses numpy's square root function to calculate the square root of 9. To run the cell, click the play button in the toolbar, or use the keyboard shortcut Ctrl+Enter. We get 3.0 as the output, the square root of 9. Notice that the notebook automatically displays the result of the last expression in a cell. This is one of the nice features of working in a notebook compared to a standard Python script, where you need to explicitly wrap that in a print statement to see the output. Let's try one more thing. Let's click into the next empty cell and type import pandas as PD, and then let's create a data frame, pd.dataframe, and within that function, we are going to put a data dictionary. So here we're importing pandas with the alias PD. This is another universal convention. We're creating this simple data frame. So notice that the syntax inside the parentheses, this is a Python dictionary, which is a collection of key value pairs. The keys, X and Y, become the column names. The values are list, those are the items inside the square brackets, and they become the data in each column. One important detail, the list must have the same number of entries. If the X has 3 items, Y needs 3 items as well. Otherwise, pandas will give you an error. So now we run the cell. So pandas displays the data in a nicely formatted table right in the notebook. This is why JupyterLab is such a powerful tool for working with data. You can see your results immediately and iterate quickly. Before we wrap up, it's worth knowing that JupyterLab can also work with conventional Python files. These are the .py files you may have seen elsewhere. From the Launcher tab, you'll notice that there are tiles under the group labeled Other. These include a terminal and a text editor. You can create a Python file and write the code within the text editor, and then run it from the terminal. One key difference in simple Python scripts is that you'll be required to use the print function to see the output, while notebooks display results automatically. For learning and exploring data, notebooks are ideal. But for bigger, larger applications, Python scripts are the way to go. Before shutting down, make sure you save your notebook. You can do this from the File menu by selecting Save Notebook, or use the keyboard shortcut Ctrl+S. You can also click the Save icon in the toolbar. It's the small disk near the icon near the top left. You may also want to rename your notebook. You can right-click untitled.ipy in B, and then select Rename Notebook. You can always give it a meaningful name, something like My First Notebook.ipy in B. Saving frequently is a good habit. JupyterLab does have an autosave, but it's always worth saving manually before you shut down. When you're finished working, the proper way to shut down JupyterLab is through its menu. Go to File, then Shut Down. This cleanly stops the Jupyter server, and you'll see the terminal window return to a normal prompt. It's also good to deactivate your virtual environment by just typing deactivate. The next time you want to work on your project, navigate to the project folder, activate the environment, and run JupyterLab again. This wraps up the series. Over 3 videos, we've gone from a fresh Windows 11 system to a fully working Python data analysis and visualization environment. In video 1, we used winget to install Python from the command line. In video 2, we created a project folder, set up a virtual environment, and installed packages with pip. And in this video, we installed JupyterLab and wrote our first Python code. You now have everything you need to start learning Python. The packages we installed, NumPy, Pandas, Polars, Matplotlib, and Plot9, give you a solid foundation for data analysis and visualization. Thanks for following along with this series on getting started with Python on Windows 11, and I hope to see you in the next video.